Pluto is a distant and mysterious world, once proudly listed as the ninth planet in our solar system. But now, surprising new statements by famous astrophysicists Neil deGrasse Tyson and Michio Kaku have pulled Pluto back into the spotlight. They've made a shocking claim suggesting that Pluto might be on a collision course with Neptune. It sounds almost impossible, but could such a massive event really happen? What would be the consequences if two celestial giants collided in the depths of space? Is this just a strange cosmic coincidence, or is there something bigger happening? Let's dive deep into this fascinating possibility and find out what's truly going on between Pluto and Neptune. Pluto, once celebrated as a full-fledged planet, was reclassified as a dwarf planet largely because of its strange orbit. Yet, despite being downgraded, Pluto remains a major point of interest for scientists. According to the latest predictions from leading experts, Pluto's orbit brings it dangerously close to Neptune's path. Astrophysicists like Neil deGrasse Tyson and Michio Kaku are both warning about the possibility of a serious crash between these two icy worlds. If this were to happen, it could have ripple effects that might even threaten Earth. But how could such a collision even be possible in a solar system that usually feels so orderly and stable? Pluto's movement around the Sun is anything but typical. Unlike the other planets, Pluto takes a staggering 248 years just to complete a single orbit around the Sun. This means that ever since Pluto's discovery back in 1930, it still hasn't finished one complete trip around the Sun. Even more fascinating is the fact that Pluto doesn't move in a neat circle like most planets. Instead, it travels along a highly elliptical and stretched-out path. Adding to the complexity, Pluto's orbit is tilted at an angle of 17 degrees relative to the flat plane where most other planets travel, making its journey through space even more unpredictable and interesting. One of the most intriguing facts about Pluto's orbit is that it actually crosses Neptune's path. For about 20 years during each full orbit, Pluto is closer to the Sun than Neptune is. This sounds like a disaster waiting to happen, but somehow they never collide. Why not? The answer lies in the delicate gravitational ballet of the planets. As astronomers began studying Pluto's path after its discovery, they noticed how different it was from the other planets. The steep tilt and strange shape of Pluto's orbit made it stand out. And the fact that it crosses Neptune's orbit only deepened the mystery even further. Pluto's continued stability despite all these complications is a beautiful example of the intricate and precise rules that govern space. One important concept that explains this is called the three-body problem. This problem involves figuring out how three objects, like Pluto, Neptune, and the Sun, pull on each other and influence each other's movements. It's incredibly complicated because the pull of each object constantly changes the other's paths. For Pluto, its interactions with Neptune and the Sun show how even tiny gravitational effects can maintain order in what looks like chaos. To keep things running smoothly, a few important space concepts come into play. The first is something called azimuthal libration. In simple terms, this means that when Pluto crosses Neptune's orbit, they are always separated by at least 90 degrees in their positions. This safe distance acts like a cosmic buffer zone, keeping the two planets from crashing into each other. Another concept is scope libration, which refers to Pluto's vertical movement. When Pluto gets closest to Neptune, it's actually far above Neptune's orbital path, adding another layer of protection against a potential collision. There's also another important idea called the VZK oscillation, named after three scientists, Voluri, Zakamska, and Kuchner, who studied how objects move under the influence of multiple gravitational pulls. In Pluto's case, this oscillation explains how it stays stable even though its path looks wild. The Sun, Neptune, and Pluto are all pulling on each other, creating a delicate balance. Even though Pluto's orbit seems chaotic, these hidden patterns keep it moving smoothly for millions of years. It's an amazing reminder that even in the seeming randomness of space, there is an underlying order. These gravitational effects work together to protect Pluto's orbit and keep it from crashing into Neptune or flying off course. The three-body problem helps us understand how their paths shift and adjust based on their gravitational tugs. Studying these complicated interactions doesn't just teach us about Pluto and Neptune, it also gives us insight into how distant worlds and stars might behave. Understanding these patterns is crucial if we want to truly grasp the forces shaping the universe around us. Interestingly, back in the late 1980s, computer models revealed that Pluto's orbit isn't perfectly calm. It's actually somewhat chaotic. Tiny changes in Pluto's starting position or speed could lead to big differences over thousands of years. Despite this chaos, special characteristics in Pluto's orbit allow it to remain generally stable over extremely long timescales. These discoveries showed scientists that even when things seem unpredictable, Some patterns hold strong, keeping cosmic systems like our solar system from falling into complete disorder. Modern simulations have also shed light on how the giant planets influence Pluto's path. Neptune has a very special relationship with Pluto. For every 2 orbits that Pluto makes around the Sun, Neptune completes 3. This ratio creates a gravitational lock that keeps Pluto from getting too close to Neptune. But Neptune isn't working alone. Jupiter's immense gravity also plays a crucial role in protecting Pluto's journey. Jupiter's pull is so powerful that it can stabilize Pluto's path for billions of years, preventing it from being thrown into a dangerous trajectory. It's fascinating to realize that Neptune, Jupiter, and even Saturn are all working together, creating a kind of cosmic safety net around Pluto. Without their combined influence, Pluto's path would likely be much more chaotic and unpredictable. Their gravitational teamwork helps maintain the delicate structure of the solar system, making it far more orderly and stable than it might otherwise be. These hidden dynamics show just how finely balanced our cosmic neighborhood really is, and how even small planets like Pluto are part of a much larger and intricate system. Without these protective mechanisms, our solar system would look completely different. Bodies like Pluto could crash into others or be thrown into deep space, triggering chain reactions that would affect many other objects. For Pluto, especially now with renewed discussions about a potential collision with Neptune, understanding its orbit is more important than ever. It helps us get a clearer sense of the dynamic forces at play and reminds us that space, though seemingly silent and empty, is constantly alive with powerful interactions and delicate balances. Pluto's situation is a perfect example of how unstable paths can still find stability through gravitational forces and precise orbital mechanics. It also shows why continuous observation and research are so important. As technology advances, scientists can create better models and simulations to understand how these fragile systems survive over millions and even billions of years. The more we learn about cases like Pluto's, the better we understand the forces that hold the universe together, and the better prepared we are to spot any real dangers lurking out there in the darkness. The unpredictable nature of Pluto's orbit highlights the concept of orbital chaos. This idea describes how even tiny differences in a planet's starting conditions, like its exact speed or position, can cause huge changes in its long-term path. Scientists have used virtual simulations to explore this, and the results are fascinating. By tweaking small details, they can see how Pluto's future orbit might twist and turn in surprising ways. These simulations reveal just how sensitive celestial paths can be to even the smallest factors, painting a vivid picture of a solar system that is both beautifully ordered and wildly unpredictable. In the late 1980s, these computer simulations revealed that Pluto's orbit, while supported by helpful gravitational tricks like azimuthal and scope libration, is still capable of wild behavior under the right conditions. Even a tiny shift at the beginning could cause Pluto's path to look completely different after millions of years. Yet, even within this chaos, there is a kind of deeper stability. Despite its erratic tendencies, Pluto's overall journey remains steady enough to last for billions of years. This fascinating balance between chaos and order shows how complex and beautiful the universe really is. Predicting events far into the future, especially for objects like Pluto with turbulent orbits, is an enormous challenge. The slightest unknown factor could change the entire outcome. Scientists know that even small shifts could eventually send Pluto on a new path, potentially closer to Neptune or even out of the solar system altogether. However, with everything we know today, it seems that Pluto's chaotic but stable orbit will continue for a very long time, kept in check by the careful dance of gravitational forces weaving through the solar system. The nature of such systems means that long-term predictions are often filled with uncertainties. While mathematical simulations offer a powerful tool to understand and predict the future behavior of celestial bodies, they also reveal the inherent limitations of our predictive abilities. These models rely heavily on the precision of the starting conditions and the intricate complexity of the interactions they attempt to simulate. Any slight mistake or misrepresentation in the initial data can lead to vastly different outcomes over time. This sensitivity makes precise long-term predictions an incredibly daunting and often unreliable task, despite all our technological and scientific advancements. Moreover, the chaotic nature of celestial orbits like that of Pluto serves as a constant reminder of the dynamic and ever-evolving nature of our universe. Even with all the progress we've made in understanding the vast mechanics of space, Pluto's erratic path shows us that our grasp of the cosmos remains limited. This particular case pushes scientists to remain humble in the face of such complexity. It forces us to accept that, as much as we have discovered, there are still countless mysteries awaiting explanation, and countless systems behaving in ways we can barely begin to predict. Studying the gravitational effects of giant planets like Jupiter, Saturn, and Neptune on Pluto's orbit provides valuable insights into the broader dynamics of the solar system. It vividly illustrates how the presence, position, and movements of massive bodies can have significant impacts on the stability, trajectory, and long-term behavior of smaller celestial objects. Every slight gravitational tug, every orbital shift, ripples through the system, reminding us that everything is interconnected in ways far more intricate than they appear at first glance. Pluto's story is not just its own but a reflection of the delicate cosmic dance playing out across the solar system. This brings us to an intriguing question. Why are major astrophysicists only now raising concerns about a potential crash between Pluto and Neptune? After all, haven't these complex gravitational forces always been at play? One key figure who helps us unpack this mystery is Neil deGrasse Tyson, a prominent astrophysicist well known for his role in popularizing cosmology. Tyson offers a unique perspective on the ongoing mysteries of our solar system and, in particular, the fascinating case of Pluto's orbit and its long-debated status within the cosmic community. Neil deGrasse Tyson, often recognized for his pivotal role in reclassifying Pluto from a planet to a dwarf planet, provides an insightful discourse on how our understanding of celestial mechanics is constantly evolving. His position on Pluto's renaming is not one of dismissal but rather an acknowledgement of the increasing complexity of our solar system. As more celestial bodies were discovered orbiting the Sun, it became necessary to refine our definitions. Tyson views this adjustment as a sign of intellectual growth, an evolution in how we categorize and comprehend the enormous diversity of objects surrounding us. His approach to celestial mechanics is deeply rooted in continuous learning and adaptation. Tyson sees the erratic orbit of Pluto not as a problem but as evidence of the richness and depth of the universe's mysteries. The very unpredictability of orbits like Pluto's inspires scientists to keep questioning, to keep investigating. His work reminds us that with every discovery, new questions arise. The more we uncover about space, the more we realize how little we truly understand. It's this endless cycle of curiosity and discovery that drives scientific progress forward. Tyson's interest in the possible interactions between Pluto and Neptune highlights the inherently dynamic and unpredictable nature of our solar system. Although the chances of a collision remain extremely low, the mere possibility invites deeper inquiry into the gravitational balances that maintain cosmic stability. It underscores how even seemingly stable systems can hold hidden instabilities, waiting to emerge over vast stretches of time. Tyson's emphasis is not on alarming the public but on inspiring awe at the forces at work in the universe and encouraging the scientific community to probe ever deeper into the unknown. Meanwhile, Michio Kaku, another renowned physicist and futurist, offers a complementary yet distinct perspective on the mysteries of space. Known for his ability to weave complex scientific ideas with futuristic visions, Kaku has become a major voice in discussions about celestial mechanics and their broader implications for humanity. His contributions help bridge the gap between academic study and public fascination, connecting cutting-edge theories to real-world impacts and future possibilities. His viewpoint on Pluto and the broader dynamics of the solar system adds another vital layer to our understanding. Kaku's views on Pluto's orbit underscore the urgent need for continuous observation and increasingly sophisticated modeling. He points out that space is not a static backdrop but a lively, constantly shifting environment. The gravitational interactions between celestial bodies, even those as distant as Pluto and Neptune, are critical to understanding the long-term evolution of the solar system. In Kaku's eyes, every small nudge or perturbation can have cascading effects over millions of years. His futurist approach emphasizes that to secure our future in space, we must anticipate these changes before they surprise us. He frames scenarios like a hypothetical Pluto-Neptune collision not just as academic curiosities but as essential reminders of the universe's dynamic nature. For Kaku, these possibilities highlight the importance of preparing for the unexpected. Future human endeavors in space, whether building colonies, exploring distant worlds, or protecting Earth from potential threats, depend on our ability to predict and understand the complex forces at work beyond our planet. His perspective stresses that staying ahead of cosmic surprises requires both vigilance and imagination. Both Tyson and Kaku converge on a critical idea. Space is a realm of endless discovery, and despite centuries of exploration, our understanding remains a work in progress. Their views emphasize that continuous exploration, advanced modeling, and a readiness to rethink our assumptions are vital as we probe deeper into the universe's secrets. They highlight that understanding celestial mechanics is not simply about knowing where planets are today but about imagining where they might be millions of years from now, and preparing for the unexpected twists the cosmos might have in store. The hypothetical crash between Pluto and Neptune, while extremely unlikely, serves as a perfect case study for the broader challenges and opportunities faced in space exploration. It underscores how even the smallest uncertainties in orbital mechanics can open the door to new questions and possibilities. The situation reminds scientists of the necessity of rigorous inquiry, cutting-edge technology, and an open-minded approach to understanding space. It's not just about confirming what we think we know, but about being ready to adapt and revise our models as new information inevitably comes to light. For both Tyson and Kaku, Pluto's unpredictable orbit is more than just a curiosity. It's a rallying call to keep pushing the boundaries of human knowledge. They advocate for deeper investments in scientific research, better observational technologies, and a spirit of perpetual curiosity. Through their eyes, the mysteries of space are not barriers but invitations. Invitations to explore, to question, and to embrace the unknown with wonder and determination. Their work inspires both the scientific community and the public to stay engaged in the grand adventure of cosmic discovery. Today there is a general scientific consensus that for many years to come, the orbits of Pluto and Neptune will remain stable, largely due to their 3:2 mean motion resonance and the powerful gravitational influences exerted by other major planets. This resonance acts like a protective mechanism, ensuring that despite their crossing paths, Pluto and Neptune never actually collide. Because of this and the other stabilizing forces at work, a direct crash between these two celestial bodies is considered highly unlikely based on everything we currently know. However, the complexities of orbital mechanics and the potential for small perturbations mean that astronomers cannot afford to be complacent. The orbital elements of celestial bodies can change subtly over time, influenced by factors we might not even fully understand yet. That's why ongoing monitoring and continuous refinement of our models are absolutely critical. By studying these bodies carefully and consistently, scientists hope to better predict their future behavior and understand the broader dynamics shaping our solar system's evolution. While the theoretical possibility of a Pluto-Neptune impact remains extremely remote with our current understanding, it highlights a much bigger point: the necessity of ongoing exploration and observation in space science. As our technologies advance, through more powerful telescopes, faster computers, and more sophisticated simulations, we gain sharper, more detailed models of celestial dynamics. These tools allow astronomers to better predict, monitor, and react to the ever-shifting behaviors of distant worlds, ensuring that humanity stays ahead in its understanding of space. Neil deGrasse Tyson's perspective on the importance of Pluto's renaming and Michio Kaku's emphasis on the unpredictable nature of celestial mechanics both underscore the same vital lesson: our understanding of the universe must remain adaptable. Science is not a static collection of facts but a living, breathing endeavor, one that must grow and change as new discoveries are made. The potential crash scenario, unlikely as it may be, illustrates the critical importance of staying curious, questioning assumptions, and always seeking a deeper understanding. Ultimately, the discussion about Pluto and Neptune serves as a powerful reminder that, despite all we know, the universe still holds vast, uncharted territories beyond our comprehension. Through ongoing research, relentless observation, and a spirit of unending curiosity, we strive to unravel these mysteries. In doing so, we ensure that our knowledge keeps pace with the ever-advancing universe, a universe that continues to surprise, to challenge, and to inspire us with its boundless possibilities.